So by asking you to integrate f of t from 0 to x, what you really end up with is back in terms of x, and it's just the integral of the first 4 terms and the general term. And the reason that they ask it like that is because when you have a definite integral, you don't have to worry about a constant, whereas have they just said let m of x equal the integral of f of x, then you would have had to have remembered to put in this unknown constant there. And in these types of problems, they try and avoid that unknown constant and ask it like that. So the bottom line is that when you're integrating f of t from 0 to x, you can go directly to just integrating the first 4 terms in terms of x and the general term, and that be your answer. So you don't have to go through finding f of t and then integrate f of t and then showing that you're going to plug in your x minus plug in your 0. Okay, and then the last one on this page, find the first 4 terms in the general term of the Taylor series for p, where p of x is f of x minus 1, all divided by x squared. So this is still along the general lines of what we've been doing. It's just that we're doing a couple of operations at once instead of just one operation. So the numerator is to take f of x, that whole thing, and subtract 1. What's going to happen when you take all of f of x and subtract 1? Yeah, the 1 minus 1 is actually going to cancel. And I'm going to go ahead and write it out on this example just so that I don't lose anybody. So f of x is 1 minus x squared over 2 plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus negative 1 to the n, x to the 2n over 2n factorial. Okay, so that's my whole f of x, and then it says, okay, we'll subtract 1 from that, so minus 1, and then divide that whole thing by x squared. Well, order of operations, when fractions are involved, you have to complete that, do what's on top, do the numerator first, and then go through and divide everything by x squared. So I've got this 1 minus 1 that will cancel, and now I can just take what's left and divide everything by x squared. Negative x squared over 2 factorial divided by x squared is what? Yeah, it's just negative 1/2. Because remember, dividing by x squared is the same thing as multiplying by 1 over x squared. So we're basically just dividing each of these exponents by x squared. All right, so the next term will be plus what? Good, x squared over 4 factorial minus x to the 4th over 6 factorial. And once again, I'm supposed to write the first 4 terms, although I've run out of terms for f of x, but using the exact same pattern would be x to the 6th over 8 factorial. If I take x to the 2n divided by x squared, that will simplify to x to the 2n minus 2. Subtract your exponents. And then I've got that 2n factorial on the bottom. And this is a 2 right there. It looks kind of like a 3. For this general term right here, we can no longer actually start with n equals 0, because if n equals 0, you would get x to the negative 2, and that doesn't match your first term. So in order to make that pattern, you would actually have to start with n equals 1, I believe. That would make it work. Yeah. And then n equals 2 would give you 4 minus 2 is n squared. So it doesn't really matter. Once you write out that general term, it doesn't really matter what n value you're starting with, as long as there's some n value that will make it work. This was an actual problem on a recent AP exam. So let's see how they're kind of asking these questions. We're letting f of x equal the natural log of 1 plus x cubed. Okay, no big deal. The Maclaurin series for the natural log of 1 plus x is given to you. Sometimes on these problems, they will give you a Maclaurin series. Sometimes they'll ask you to create a Maclaurin series, kind of like I did on the front page of this. I asked you to create the Maclaurin series for cosine x, and then we did a bunch of stuff with it. But sometimes they'll just go ahead and give you a Maclaurin series. Use that series to write the first 4 non-zero terms and the general term for the Maclaurin series for f. So what it's asking us to do is to use this one that they've given us to create a Maclaurin series for f of x equals the natural log of 1 plus x cubed. So what is the relationship of the natural log of 1 plus x to the natural log of 1 plus x cubed? Or what can I do to change the natural log of 1 plus x and make it into the natural log of 1 plus x cubed? What could I replace the x with in the original one to make my new one? X cubed. If all I do is replace that with x cubed, then I will have the natural log of 1 plus x cubed. So all I need to do is take this Maclaurin series and substitute x cubed in everywhere I see an x. All right, so f of x is what they're calling the new one that I'm supposed to create. So f of x is going to equal x cubed minus x cubed squared would be x to the 6th over 2. X cubed cubed will be x to the 9th over 3. First 4 terms, I need one more. X cubed to the 4th will be x to the 12th over 4. And then my general term, x cubed to the n power will be x to the 3n and over n. Why don't I have any factorials in these? I'm used to seeing factorials. Right, they've already been canceled out. When they created the Maclaurin series for the natural log of 1 plus x, the term in front of, say, x cubed involved the third derivative divided by 3 factorial. So they simplified the third derivative over 3 factorial to be just 3. So don't let that freak you out. All right, part B. The radius of convergence of the Maclaurin series for f is 1. Determine the interval of convergence. Show the work that leads to your answer. So on last night's homework, when we were finding the interval of convergence, you basically had to start by doing the ratio test and essentially finding that radius of convergence. But they've pretty much already done that for us. All we have to, if we know that the radius is 1, all I have to do is figure out where is the series centered and then go 1 in each direction and test my endpoints. So if you look at part A, that series that we created, where is that series centered? Good. F of x is centered at x equals 0. So if the radius of convergence is 1, then my endpoints of the interval of convergence will be what? -1 and +1. And if you think, I mean, you've got to think that in your head to work this problem, and if you think it, you need to write it down. All right, so to find the interval of convergence, I have to test my endpoints. So when x equals a -1, my series is going to be, one of the reasons that they have you write this general term is because another way to write f of x, and they don't expect you to do this in part A, but is just the sum of that general term. And it looks like I would start, if I write this in sum notation, I would start with n equals 1 to get my first term of x cubed. So the whole point of the general term is to be able to rewrite that series in the summation notation. All right, so if x equals -1, then my series is -1 to the n plus 1 power times -1 to the 3n power all over n. And I need to determine whether this converges or diverges. Can I multiply -1 times -1 up on top? No. The exponents are not the same. However, I'm multiplying like bases, so what can I do to the exponents? Add them. Good. So it would be negative 1 to the 4n plus 1 power over n. Now be careful, because at first glance, this may look like it's alternating. However, when you plug in n equals 1, what is that exponent on the negative 1? 5. When you plug in n equals 2, what is that exponent? Doesn't really matter. It's another odd exponent. If you plug in n equals 3, do you get an even or an odd exponent? Odd. So this is always negative 1 to an odd power, which will always be negative 1. So that is not an alternating series. It's actually just negative 1 over n, which another way to think about that is negative 1 times the series 1 over n. And does 1 over n converge or diverge? It diverges, meaning its sum is infinity. Well, negative 1 times infinity is negative infinity. It's still not a finite number, so that one also, so that diverges. Now, if you had seen this negative 1 to the 4n plus 1 power and thought, oh, that's an alternating series, does the alternating harmonic converge or diverge? It converges. So you've lost a point for not paying really close attention. So be careful with that. All right, the other endpoint is at x equals 1. Unfortunately, this one is easier to deal with. All right, so n equals 1 to infinity of negative 1 to the n plus 1. And then 1 to the 3n power, no matter what, is always just going to be 1 over n. So does negative 1 to the n plus 1 alternate? Yes. So I have the alternating harmonic, which converges. So therefore, my interval of convergence does not include negative 1, but it does include positive 1. Write the first 4 non-zero terms of the Maclaurin series for f prime of t squared. And then if g of x equals the integral from 0 to x of f prime of t squared dt, use the first 2 non-zero terms of the Maclaurin series for g to approximate g of 1. That's a lot to deal with in one problem. Start off with the first sentence. Write the first 4 terms of the Maclaurin series for f prime of t squared. All right, we can do that. F prime of t squared would be f prime of x, but going back and substituting in a t squared. So let's start with f prime of x. And remember, f of x is what we created in part A. All right, so f prime of x, the derivative of the first term would be 3x squared. And then the derivative of x to the 6th over 2 is 3x to the 5th, which would be minus 3x to the 5th. All right, what's the derivative of the next term? Plus 3x to the 8th. And the derivative of the last one is minus 3x to the 11th. Do I need to do the general term? No, it didn't say general term, so let's not do it. So there's f prime of x, so f prime of t squared will be 3, and then t squared squared is t to the 4th, minus 3t to the 10th, t squared to the 5th would be t to the 10th, plus 3t squared to the 8th would be t to the 16th, minus 3t to the 22nd.